To our third topic, smartphones, applications with the database connection. Okay. So I guess a lot of you actually already know about what a smartphone is, and you've probably also created a smartphone application, but I'm not sure actually how many created an application with database connection. So, is there anybody who actually created a smartphone application with database connection? Okay, so I see a few. Okay, so how do you usually manage data in a smartphone application? If you create an application, if you create a game or some application, how do you manage data? In files? In files in memory? Okay. I guess because most of your applications are pretty simple, you really don't need a database, and you just use the data and throw it away. Okay. If you need to write something, you probably just use files and just do simple things. But using a database makes your life more easy. So, of course, you need a lightweight database inside the smartphone, which is already provided. But it makes it much more kind of independent from your application. Okay? So, if you use a database, then management of your data becomes much more clean. Okay? And when your program becomes much more complicated, then using a database instead of files or in memory is much more better. So, in the third part of our lecture, we'll look at how do you actually connect a database with your smartphone application. Okay? So we'll have a brief overview of smartphones and smartphone application development, smartphones and the databases, and the platform we're going to look at is the Android platform. So, because of course the Android platform doesn't need Apple computers, and you just could download a lot of nice tools for free. Okay, so we'll look at some details for preparing the development environment for Android, and I'll give a simple Android example application without the database. Okay, so in this first part of the lecture, we're not going to actually talk a whole lot about databases. Okay, so in the next lecture, you'll see how you create the application with the database. So, what's a smartphone? I guess almost everybody has a smartphone. It's a mobile phone that offers more advanced computing ability and connectivity than a contemporary basic feature phone. Okay, so, of course, this is a very kind of broad definition. One important thing is the user can install and run your own advanced applications. So this ability actually makes it like a very small computer, and the smartphone market is actually eating up the PC market. So we can see that gradually the PC market is going down. So if we look at the smartphones by operating systems, there's different operating systems. Of course, Android, Samsung, LG, all these companies using Android. Apple, RIM, Symbian, Windows Mobile, Linux, and there's also others. So the first generation smartphones kind of course, Apple did a very good thing with the iPhone. The first generation, right after the feature phones, there were some Linux-based, very primary low-featured smartphones didn't work very well. But after that age, Android came out, and the iPhones are working much more better. And do you know which actually smartphone uses RIM? It's Blackberries. You've heard about Blackberries? Okay. So it's a Canadian company, and so this is a picture of the 2010 Q2 smartphone sales by operating systems. Okay, so it's about 2 years, a little bit more than 2 years before today. So we could see about Android 17%, Apple 14%. Okay, Symbian is Nokia. So at that point, Nokia had a very high market share, RIM, and Android and Apple, and then you can see a little bit of Windows and others. But if you go to Q4, you can see that the smartphone sales, Android goes up to 53%. Okay, so the Android market actually boomed up, and you can see that there's two lineups: the Android smartphones and the iOS. Apple's 19%, so Apple also increased a lot, and RIM, Windows Mobile, and all the others followed. Okay, so of course this was in 2010, and now you can see that there's two big players, the Android and iOS. Okay. So we're seeing a lot of lawsuits going on with Apple, Samsung, and I'm not sure who's winning, but both sides are saying they are winning, but we'll see. Okay. So if you look at Android and iPhone, so there are a few different kind of things. Basically, if you're going to create an application, in Android, the language you use is going to be Java. So that's a good thing, because everybody, computer major, actually knows Java. If you want to develop with iPhone, iOS, you'll have to learn a new language, which is Objective-C. Okay. So Objective-C is actually, although it has the C and objective thing, so it's an object-oriented language, but kind of very similar to C++, but it has different kind of notations. Okay, so getting used to it will take some time, but it's a very nice language to learn. Okay, so if you know any Java language, you can easily actually migrate to Objective-C. Okay? The SDK for Android is Android SDK. iPhone has the iPhone SDK. And the development environment that you would use for Android is the IDE, Integrated Development Environment, would be the Eclipse. Okay? On the other hand, if you're using iPhone, the IDE that you use is called Xcode. So you download Xcode, and using Xcode, you can create iPhone applications. Okay? Eclipse is free. It's actually not only used for smartphone application development. It's a general Java development tool. So you can actually develop Java applications with Eclipse, and the only thing you have to do is install new plugins, and you can actually use Eclipse with other application development. Of course, Android was created by Google. Okay, that's the software part. The hardware part is the manufacturers are not Google, but you have other companies are the manufacturers. Samsung, LG, and blah, blah, blah. Okay? But if you kind of see that something that's interesting is, of course, this is a little bit of side story, but nobody is actually suing Google. Okay, so if you look at the creation of Android, all the Android smartphone manufacturers are getting sued, but Google is not getting sued by anybody. So why is that? So actually, if Android has a problem, Google should be sued directly by Apple. Does anybody know how that works? Okay. So it's this is why engineers also need to be understanding about a lot of different laws and all those kind of business. Okay? So Google did a very intelligent thing. Well, I'm not sure if it's intelligent, but when they created Android, they give out the code for free. Okay? So you can use the code, but if there's any problem, there's no responsibility for Google. Okay? You can use Android, but when you make a smartphone, if there's any problem, all the responsibility goes to the manufacturers. Okay? So that was their agreement, and that's why if iPhone wants to sue anybody, it doesn't sue Google, it sues the manufacturers. Okay? So it's very interesting kind of business tactic. So Google is not losing any money by the lawsuits. Okay? Although they give out the Android for free. So iPhone, okay, the ID is Xcode, the creator is Apple. They also have their own hardware. The application download is done by App Store. For Android, the applications are downloaded. Now it's called Google Play, right? Okay, so from Google Play, you can actually download the applications for Android. So it's a very interesting kind of thing that's going on. So when I first created the slides, we didn't know actually who was going to win. There were no lawsuits at that point, but now it's kind of getting very interesting. You might want to kind of understand the behind stories. So why is Google giving out Android for free? Have you ever actually thought about that? When Google actually purchased the company to get the Android, okay? So they didn't build it themselves. They actually bought a company that created the Android, and they are providing it for free. So they actually gave a lot of money to create this Android. But why are they actually giving out for free? Because Google's main revenue, the money that they earn, is not by the software. Right? So Google's business is based on 광고, advertisement. Okay? So that's why on the search engines, okay, they provide a search engine, but they're not actually making money by their search. They're making money by advertisement. But if the iPhone comes out and the mobile market is dominated by iPhone, then everybody uses Safari. Okay. The advertisement market is going to go to Apple. So we can see that there's a bigger and bigger share going for advertisement on the mobile market. So that's why Google wanted the mobile advertisement market, and they're giving out Android for free. Okay. So that's their main business target. Okay. And because of that, they're not actually interested in the hardware. Okay. So they just want the advertisement. They give out it for free, but all the responsibility are moved to the manufacturer. 그러니까 구글이 굉장히 비즈니스를 잘 하는 거예요. 굉장히 보시면 소프트웨어에 대한 책임은 지지 않고 공짜로 줘요. 그래서 제조사들이 다 법적인 책임을 지게 돼 있어요. 그래서 다 소송당하고 있죠. 근데 또 안드로이드를 통해서 모바일 광고 시장은 또 가져가고. 그래서 여러분들 보시면은 IT가 사실은 세상이 반반입니다. 기술만으로 살아남을 수 있는 건 아니고 실제로 굉장히 중요한 요소들이 많습니다. 그래서 여러분들 중에 혹시 CEO가 나온다면 IT 기술도 잘 알아야 되고 마케팅도 잘 하셔야 돼요. 제가 봤을 때는 한 50대 50이에요. 그러니까 기술 70, 마케팅 30 이거 가지고 살아남기 어렵고 사실 마케팅이나 이런 비즈니스 쪽도 그 정도 같이 이렇게 비중을 둬서 해야 실제로 좀 살아남을 수가 있는 거예요. Okay. So we can see this kind of interesting thing going on with Apple and the Android. In our news, we're seeing that like Samsung is winning, but actually we're not sure. Okay, so smartphones and databases. Inside the smartphone, you actually have a SQLite database. So even in the iPhones, in Androids, you have this open source SQLite database. It's a software library that implements the SQL engine, and it's self-contained. Okay? So what self-contained means is there's no external dependencies on the library and the operating system. So all the important parts of the library and operating system related calls are kind of neutral. That's why you can use SQLite on iPhone and also on Android. Okay, so it's self-contained. It's serverless. Okay, so the process that wants to access the database directly accesses the files. So serverless means basically you send a request to some server component and the server will access the data files. But here, actually, the database is embedded in your process. Okay, so inside your same process, you have your database. Okay, so that same process will directly contain the database, so it will directly access the files. Okay, so it doesn't have a kind of server concept. Zero configuration. There's no setup procedure, no configuration file. Very easy installation. Of course, it's a database, so it's transactional. So all queries and updates are ACID queries. Okay. Stored in a single cross-platform disk file. Okay. So it's inside a single file. Okay. Written in ANSI C. C language is used for the creation. It's open source, so you can go to that site to actually get the SQLite. Okay. SQLite is a popular choice for database engine in cell phones, PDAs, MP3s, set-top boxes for televisions. Okay. So it's actually almost in all of the embedded systems that you need a database. Why is that? Because it has a small code footprint, very small program, efficient use of memory. Okay. Memory usage is very efficient. This space and this bandwidth is very good, and highly reliable and requires no maintenance from the DB. Okay. So it has all these kind of nice features. And it's very popular in embedded systems. So if you look at Android and SQLite and iPhone and SQLite, for the Android operating system, the Android provides full support for SQLite databases. It actually includes a SQLite database. Any database created in application is accessible by name to any class in the application, but not outside the application. So this basically means that inside your application, you'll create a database, and that database is only accessible inside your application. Okay? So it's also kind of connected with the serverless concept. So your application will have your own database. Okay? And this is the package, android.database.sqlite database. Okay? So there's a SQLite database class. For the iPhone operating system, if you want to use SQLite, Xcode is the development environment, IDE, and together with Xcode, you will install this Firefox SQLite extension. Okay? So you install that with Xcode. There's a lot of SQLite 3 underbar kind of functions that you can use. Okay? So in iPhone, if you want to use SQLite, you'll have to install these extensions and use those functions. Okay? On the other hand, Android will use this Java kind of class, okay, with namespace. Okay? Okay, so what is Android? Of course, everybody probably knows what an Android is. It's an operating system. It's a software stack for mobile devices that includes operating system, middleware, and some key applications. So we'll look at this software stack. The Android SDK, there's a software development kit, and this Android SDK provides the tools and APIs that you'll need to develop applications on the Android platform using the Java programming language. So when you want to create an Android application, of course you'll have to have the Java language installed, but also the Android SDK. So these are the Android features. Application framework. Of course, you can reuse and replace the components using this application framework. Inside Android, there's a virtual machine called Dalvik. So, like if you're using Java, there's a JVM, Java Virtual Machine, that runs all the Java commands. Inside Android, there's a Dalvik virtual machine that will run all the Android commands. So it's optimized for mobile devices. You have an integrated browser based on the open source WebKit engine. There's a graphics capability, 2D graphics library, 3D graphics libraries. And this is what we are interested in. There's also a SQLite for storing data. Media support for audio, video, and still image formats. So MPEG-4, H.264, MP3, JPG, PNG, AAC, AMR, all these audio, video formats are supported. And based on your hardware, you can have the GSM telephone. Bluetooth, Edge, 3G, and Wi-Fi, camera, GPS, compass, and accelerometer. Also, rich development environment. Like you have the device simulator, tools for debugging memory and performance profiling, and plugin for the Eclipse IDE. So we'll look at this development environment, how you install the development environment, and actually start using this environment to create Android applications. Okay? This is the Android architecture. So if you get an Android phone, you'll see all these. It has a contact, address, some phone, browser, all these applications installed. In the application framework, you can see that there's a lot of components that you can use. The libraries, inside the libraries, these are the kind of APIs that are provided for your program. One of the interesting things we want to look at is SQLite. Okay? So you'll be using the SQLite library, and the Android runtime has, of course, some core libraries, but also a virtual machine, Dalvik virtual machine for running the codes. And the lower level is a Linux kernel. So Android is based on a Linux kernel with all these capabilities. So in Android, you have these applications with the set of core applications. And the application framework, developers can use the framework APIs to develop rich and innovative applications. That's what we've just seen in the previous slide. The application framework with all of these nice components. Okay? And libraries contain C and C++ libraries. One of the libraries we've seen, which we're interested in, is the SQLite library. Android runtime provides the most of the functions available in Java. Okay, so it's very similar to the JVM, and at the lowest level there's a Linux kernel. Okay, so that's the architecture of Android. And now let's look at how you kind of start preparing for your development environment. So you go to this site and you can see these kind of steps for developing an Android application. First, of course, you need to prepare your development computer. So check your system requirements for installing the Android SDK. And you'll first want to install the JDK and Eclipse. Okay, so you'll first need Java because you're developing with Java. And this is going to be your IDE. Of course, there's probably a higher version for these tools. And then now you want to install the SDK starter package for Android. Okay. So you can download it from here and set the path for the installed location. The next thing you would want to do is install ADT plugin for Eclipse. So because Eclipse is our development environment, for Eclipse you want to install a plugin which is called Android Development Tools plugin. It's the ADT, and you install it for the Eclipse. And the way you do it is you want to set up a remote update site. And then finally you add the Android platforms and other components on the SDK. Okay. So we'll have a quick look at these steps. The first step is preparing your development computer. So confirm that your development computer meets the system requirements. Okay. So you have the supported operating systems: Windows XP, Vista, Windows 7, Mac OS X or later, and Linux. Okay. So these, of course, you know, probably most of you have Windows XP or Windows 7. And then you can download the JDK. Okay. So first thing, you'll need Java. Of course, everybody kind of probably has Java installed. So here's the steps for installing Java from Oracle. And then the next thing you would want is Eclipse, because Eclipse is going to be your development environment. So install Eclipse. If you need to install Eclipse, you can download it from here. Okay. And the next next thing you would want to do is install the SDK starter package for Android. Okay, so download the Android SDK starter package from here. And after you download it, unpack the Android SDK archive to a safe location on your machine. So you'll provide a path to actually do the installation. So here's a very kind instruction on doing that. On Windows, right-click on My Computer, select Properties, blah blah blah, and you can click on the path, which is under the system variables, and you want to add the full path to the tools directory. Okay. So here's how it looks. Downloading the SDK starter package. Here's the system properties dialog in your computer. So once you follow those system properties, kind of click on blah blah blah, and then you can see that you can set up the environment variables. So you would want to set up the path for the tools directory, Android SDK Windows and tools. Okay. So edit the system variable. And after you do the Eclipse installation, you would want to install the ADT plugin. So there's a different kind of plugins for Eclipse. So the good thing for Eclipse is because if you want to use Java, it's a basic tool. If you want to add some plugins, then you can actually use the Eclipse for different development platforms. Okay? So in our case, we want to add some new things, smartphone, Android application development to the Eclipse development environment. So we're going to add an ADT plugin. So this ADT is Android Development Tools. Download the ADT plugin for Eclipse. Okay. So in Eclipse, start it and then select Help Install New Software. So here's the menu, and once you go there, you can see that you can click on Add and add some new softwares into Eclipse. Okay. So you want to click the Add button, and then you'll see this Add repository. So in this Add repository, you can put this URL. Okay? So from this repository, it'll pick up all the ADT plugins. So click Next, read and accept the license agreement, and install any dependencies. Okay? So click on Next, and then finish the licenses. Okay? Okay. Now you would want to configure the ADT plugin. Okay? So now the ADT plugin is there, and going through this Eclipse Window Preferences menu, Window, and then the Preferences menu, you can open the Preferences panel and configure the ADT plugin. So in the Preferences dialog, you go to Android, and you can see that this kind of dialog pops up. Select the Browse, and you can locate your SDK directory, Android SDK Windows. Okay, so by providing this SDK location, you do the configuration. Click Apply, then OK, and you can basically see like a bunch of targets like this. Of course, there are more higher versions than this target name appearing in this list. Click Apply and OK. So now you want to add some Android platforms, okay, and other components. So now your ADT is ready, but based on what kind of different platforms you want to do the development, you have to add those. And here's how you can actually do it. Launching from Eclipse ADT, okay. If you are developing in Eclipse and have already installed the ADT plugin, follow these steps to access the Android SDK and AVD Manager. Okay, so if you open Eclipse, select Window, and you get this Android SDK and AVD Manager. Okay. So in here, you can see that there's available packages, and you can, see that you want to add on all these kind of packages. SDK platform, there's 1.1 up to 2.2. Of course, there are higher versions now. And you can add those platforms into your Eclipse development environment. Okay. Click Install, selected, and you can see that all these things kind of are added to your development environment. Okay. So that way, your Eclipse now becomes a tool to do the Android development. Okay, so by adding in your SDK and your platform information, then you're ready to go. Okay, so click Finish. There's all these packages installed, and you're done. Okay, so the preparation step is actually not that complicated, but you just need to know what steps you have to go through. Okay? So you need Java, you need the SDK, and you also have to do a thing. You add the plugin to Eclipse, okay? And you're ready to go. Okay? Here's a very simple Android example application. Okay, so for those who haven't created an Android application, this probably might be difficult to understand. For those who have created an application, it might be a very simple like Hello World example. So the Hello Android example is, you can get it from here. These are the steps we'll go through. We first create an AVD, Android Virtual Device. Okay, so this is like the emulator. So in Eclipse, you want to pop up your emulator to run your codes and see how the thing actually works. You create a project, create the source, create the user interface, run it. Okay, and these are one example. Another is using an XML user interface. So in Android development, the simplest way to actually create the UI is using the XML UI. So you don't have to do a lot of coding, but you just create an XML file for setting up your buttons and your user interface. Okay? So either way is okay, but this has a good thing and a bad thing. If you want to do a lot of customization and you want to have a very complicated UI, then the XML UI might have some problems. Okay, if you want a very complicated one. And we'll look at debug project. Okay? So if you want to have a very complicated one, you probably might want to create your own UI components and do that. Otherwise, the simplest way is to do an XML UI. So what is an Android virtual device? It's configurations of your emulator options. So like in your Android device, you want to know how much memory you want to set up, how much memory, what's the processor speed, and those kind of things. And then that emulator option will be given to your Android virtual device to actually imitate the real machine. Okay? So it's basically an emulator, and it's time to get up. Okay. So yeah, the emulator emulator has those sound options, I think, also. So it'll let you better model the actual device. So inside the Android SDK, you want to be careful because there's no pre-configured AVDs. You'll have to configure your own Android virtual device before you actually want to run it and see the result. Okay, so you need to create an AVD before you can run any application in the Android. Okay, so remember, before you want to create the Hello World application, configure your AVD, Android virtual device. Okay. So here's how to create an AVD. Select Android and the AVD manager. Okay, Android SDK and AVD manager. And inside here, you can see that there's a virtual devices menu. Okay, so here's going to be the AVD name, target name, platform, API level, and blah, blah, blah. Okay? So you want to click New, and you can create your own emulator. So I'm going to call my emulator my AVD, the target. So this is, the target means which version your compilation is going to go through. Okay? So when you do the build process for your codes, then based on the target, your codes will be compiled for that target. Okay, so Android 2.1 update 1 API level 7, that's going to be my target for the code build, and you create an AVD. Okay? So now let's create an Android project from Java Eclipse. You click on New, on Project. So I guess you probably used Eclipse in your Java class. So you create a project. And inside the project menu, you can see now an Android project popping up because you've kind of added the SDK, your plugin, Android project. So the project we're going to create will have these information. The project we're going to create is called Hello Android, the project name, Hello Android, and the application name is going to be Hello, Android. So the application name shows here, that's going to be Hello Android, and the package name we're going to use is com.example.helloandroid. So the package name shows like this. Okay, so, or you can have your own private namespace. We create an activity called Hello Android. You check the create activity, and that's the activity we're going to create. And click on finish. Okay. So once you do that, then what happens is you'll see that there's an hello android.java file created. Okay, so this was their project name, and inside the source directory, you can see that there's a hello android.java file. And if you open the hello android.java file, then it has these codes created. Public class hello android extends activity, and you can see that there's a public void onCreate method with a super.onCreate set content view r.layout.main. So the set content view actually sets up what the user interface looks like. Okay, so you have to go to r.layout.main. This is based on XML kind of way to do things. So what we're going to do is actually construct our own UI with our codes. Okay, so we'll kind of edit these codes, and if you look at the onCreate method, under the super.onCreate, these codes are changed. Okay, so in the onCreate, we changed this part. Instead of set content view, what we do is we're going to create a text view called TV. Okay. And we're going to do a new text view with this reference given to the text view. And on this text view, we'll set the text hello, Android. Okay? So this is manually creating your own controls and setting the content of that control, and then you set the content view TV. Okay? So what this will do will print out a hello Android as a text view on your user interface. So that's a very simple way to do it with your own Java codes. And what happens when you run this application is you select the Android in run menu, there's a run, and select the Android application, then this will pop up for some time. It takes some time to kind of start up. So after some time, so wait for a while, and then you'll see that it says hello world, hello Android. Okay? So you can see that this text view it's not very visible from these slides right now, but you can see that text view content is going to be printed out on your Android emulator. Okay? So that's how you do it with your own Java codes. Now, when you first, by default, create your program, your codes, it'll actually do an XML layout. And we changed the XML layout to our own text view components, and we did that application. But now, if we try to use the XML layout, if you look into the resource folder, this is the source folder. Under your project, there's a resource folder. And inside resource folder, you can see that there's a layout folder. And inside this layout folder, there is a main.xml file. Okay? So if you open this main.xml file, you can see something like this popping up. Okay? So it has linear layout tag, text view tag, okay? And so inside this linear layout tag, you have a text view tag. And inside the linear layout, you can see that there's these weird kind of some strange commands. Android orientation equal vertical, Android layout width equal fill parent, Android layout height equal fill parent. Android, inside the text view, you can see Android layout width equal fill parent, Android layout height equal wrap content, Android text equal, and there's this 골뱅이, okay, string, hello. Okay, so this Android text shows you want to use a string resource, and the string resource name is hello. Okay? So this actually will get the resource for your string content and print out on your text view. It will do the same thing. Okay. So we want to replace the code like this. Okay. Text view. We use this text view. Okay. And then Android ID layout width, layout height, and the Android text equals string hello. Okay. So in this XML file, if you replace it like this, then basically you'll get the same thing. But if you want to change the string content, where you go is resource. Under resource there's values, and there's a string.xml. Strings.xml file. Okay? So if you open that strings.xml file, it has all the content for your strings. Okay? So for your string hello, this is the content. Hello Android, I am a string. string name, application name, hello Android. So what we want to do is we want to use the string name hello, and the content is going to be hello Android, I am a string resource. So this is what we want to print out on the screen, and this is like an ID of the string. Okay? So hello is the ID of the string, and you want to use it like this. Okay? String name, application name, this is the ID of this string, and the content is going to be hello Android. Okay? So there are various reasons why you maintain this different string file. Of course, one is because it's very easy to actually maintain them all in one file. You can see which message is going to be printed out or going to be managed using this single strings file. Okay? Another is because internationalization is more easier. Okay? So if you want to have a Korean version of your application, all you have to do is just replace the strings file. Okay, so for an English version, you have all these messages in English, but because the ID is the same, now you don't need a programmer to create a Korean version of your program. If you want to create a Korean version of your program, all you need is someone who can translate English to Korean. And you give this file to that translator, and they'll give you a Korean file, and then you have a Korean version of your software. So that's how internationalization is done. 그래서 여기 이제 숨겨진 철학을 보시면, 물론 스트링 관리를 편하게 하기 위해서 이렇게 한 파일로 관리하는 거죠. 아이디도 주고, 뭐 그러면 내가 어디 메시지 바꾸고 싶다. 그럼 여기만 보면 바꾸기 편하죠. 그렇죠? 근데 또 다른 문제는 이제 국제화, internationalization이 굉장히 편하다. 그래서 소프트웨어 보면은 미국에서 출시된 지 얼마 뒤에 바로 한국 버전이 나오죠. 그죠? 그거는 소프트웨어를 새로 만드는 게 아니라 요거 번역만 해가지고 갈아 끼우기만 하면 이제 한국어 버전이 됩니다. 그래서 중국에서 출시하고 싶다? 중국어로 번역해서 그 파일만 교체하면 중국어 버전 됩니다. 그래서 여러분들이 이제 사실 굉장히 아마추어는 그 코드 안에다가 스트링들을 다 박아 놓는데 프로페셔널하게 되면 여러분들이 진짜 어디 국제적인 그 소프트웨어를 만드는 회사로 가면 이렇게 스트링들을 리소스로 따로 관리를 해도 돼요. 이렇게 해서 이제 외국의 소프트웨어를 다른 버전으로 만들 때는 그것만 살짝 바꿔서 내보내는 거죠. So you just need to change your strings to XML file. Okay. And you want to modify your Hello Android class. This is the original thing that we've seen. Set content view r.layout.name. This actually points to the main.xml file. Okay? So with this XML-based UI, if you run it, then the string will be shown. Hello Android, I am a string resource. Okay, so you run the history, run history, Android activity, and you get this. Okay. Okay, we want to do a simple debugging. Okay, create an error and see how it kind of shows up. So in your code, we are going to say we're going to give this error codes. Object O equals null. We're going to give a null object, and then try to call a method on that null object, o.toString. So that will create an exception. Okay, so at this point, an exception will occur, and you will have a problem running the program. So let's see how that works out. So if you try to compile it and run it again, then probably your printout shows it better, but it pops up with this message: sorry, the application Hello Android, blah blah blah, unexpected. Hello Android has stopped unexpectedly. Please try again. Okay, and you do a force quit to terminate and close the emulator. So if you want to actually do some debugging, you can set a breakpoint on the line, okay, So here's the code, object O equal null. So if you set a breakpoint on here, you can see all the things that are happening in, like this name is the value, this object has this value. Okay? So if you know how to do the debugging tools, then your life is going to be much more easier when you create applications. Okay? So first thing, learn how to use breakpoints. Okay? Then you can monitor the values in your debugger. Okay, so we're done with the first part of the smartphone applications, and we'll look at more database SQLite details in the next class. Okay? So let's wrap up today's class.